My name is Nana Edu, and you can call me Say Nana. Remember to like this video, share this video, and don't forget to subscribe to my YouTube channel. And don't forget to as well click on the notification bell so that you can get all videos on time. In our previous lesson, we have looked at an approach to solving a modeling question in linear equation where we use the gradient and the equation of the line. Before we go on to looking at the inequality curves, let's look at another approach to solving the same question. So we want to consider revising with the question, and we want to consider a different approach to solving this question, right? So the question says that a local electronics store is selling a new smartphone model. The store manager has recorded the number of smartphones sold and the corresponding price for each week, right? So we know the data. The data is as follows. You have week 1, the price is 800 Ghana cedi, the number of smartphones sold is 30. When the price is 700, the number is 40. When it's 600, the number is 50. When it's 500, the number is 60. We need to construct a linear function and then predict the number of smartphones that will be sold if the price is reduced to 200 Ghana cedi. So let's look at how we can use a simultaneous equation approach to be able to solve this, right? So basically, before we do that, let's draw a table so that it looks clearer for us. So we have a table here where we would have the week, and then we will also consider the price, and then the number of goods that are being sold, right? Or number of phones that are being sold. So we'll consider the week, we'll consider the price, and then the number of items that are being sold. So let's have the week here. And in the week, we have week 1, week 2, week 3, and then week 4, right? And in our second lane, we will consider the price of the phone, and then we'll consider N, which represents the number that are being sold, right? So we know that the first week, the price was 800 cedis. The storekeeper was able to sell 30 of them. 700 cedis is sold 40. 600 cedis is sold 50, and then 500 cedis sold 60, right? So we have this table. So in this case, we are going to consider the function. Now we know the function n of p is equal to m of p plus c, or we can say n is equal to m of p plus c. So let's consider if our p is equal to 600, right, and our n is equal to 50. We are substituting p and n into the equation here. So it means that you are going to have 50 to be equal to, right, 600m plus c. Let's call this equation 1. So we'll call this equation 1. And then in the second instance, we can pick any two values as well. Let's use 800 for p. So p is equal to 800 and n is equal to 30. So in that case, we are going to have our p, right, or our n, which is 30, to be equal to 800m plus c. And let's call this as well equation 2. So from picking any two values, you have been able to get two simultaneous equations, which you can write side by side. So you can have one equation being 50, right, or 600m plus c is equal to 50, which is equation 1. So we've just written it by using the MSC first and bringing the constant to the other side. And then we can also have 800m plus c to be equal to 30. We'll call this equation 2. So we can use the elimination method where we'll subtract one equation from the other. So let's say equation 2 minus equation 1 means that you are going to have 800m minus 600m, right? And then we have plus c minus c is equal to 30 minus 50. So that gives us 200m, right, is equal to negative 20. So we'll divide each of the sides by the coefficient of the m, which is 200, this side by 200. And that implies that our m becomes equal to negative 0.1, right? So negative 20, right? Negative 20 divided by 200, let's be sure of that, will give us negative 0.1. That is right. So now that we have negative 0.1 for m, we can put m, which is equal to negative 0.1, into any of the equations. So let's put it into equation 1. So that implies that you are going to have 50 to be equal to 600 multiplying negative 0.1, right? Plus c, so that we can find c. So we have 50 is equal to negative 60 plus c. So it implies that our c becomes equal to 50 when we add 60 to both sides of the equation. We are going to have plus 60. Then our c becomes equal to 110. Right, so now that we have our c to be equal to 110, we can substitute our c and our m back into the equation n of p. So n of p becomes equal to, right, negative 0.1 p plus 110. So we have gotten the modeled equation. So that is a model equation. Now, on the other hand, the question was saying that if the price reduces, so now the price has reduced to 200 Ghana cedis, right? We know that we can substitute that into n of p to be able to get negative 0.1 multiplying 200 Ghana cedis, right? And then plus 110. So it means you have n of p to be equal to negative 0.1 multiplying 200 will give us negative 20 plus 110. And we have our n of p to be equal to 90. So we can conclude that, right, the storekeeper will sell 90 new smartphones when the price is reduced to 200 Ghana cedis. So we have looked at a different approach to solving the revision question, which is a modeling of linear equation. And in this type, we have been able to resolve the equation or the values given into a simultaneous equation where we've been able to find the variables, and then we've substituted the variables back into the equation to get the linear equation, and we've been able to find the number of phones that will be sold when the price is reduced to 200 Ghana cedis. In our next lesson, we want to look at the graphical approach, right, where we'll draw a graph and then we'll use that approach to be able to solve the same question. Remember to like this video, share this video, and subscribe to my YouTube channel. See you in the next lesson.